How things are going?
Good evening, sir. Suffering from corona, sir.
Uh, so all are well, na? So how many of you have downloaded data, what I have shared?
I have downloaded, sir.
Downloaded, sir.
Okay, very good. So you have kept it in Google Drive, correct? Because,
Yes, sir.
yeah, so you just unzip data, keep it in Google Drive. So what we are going to see is the case study on CNN. So who is going to summarize what we have learned in last few classes? Who is going to summarize CNN? Who is going to do it? No one? No one willing to take a chance. Rajnikant, you can try it out. Abhishek ji. Rajnikant is not there? What happened? He's not responding.
Sir, in the last class, we discussed the convolution. We discussed the first, suppose there is input image and how we do the filter and the features map. And then we discussed the ReLU layer. And after that, what is the max pooling? And in the max pooling, which means a problem with the output feature map is that they are sensitive to the location of the features of the input. And then we discuss the one example in the website.
Okay. So what is use of convolution layer?
To classify the images.
Now what this convolution is doing?
Convolution is reducing the number of parameters.
So size of the images, correct? So basically you cannot, so when you receive image and after transforming it, it may happen that the size of the matrix is 255 cross 255 because it contains 255 pixels. Basically 0 to 255, correct? So if you just flatten this matrix and pass it to our neural network, the parameter is too high to compute, estimate. Correct? So you cannot do it this way. That's why there is a method of convolution where you reduce the size of the image, and there are furthermore steps. After flattening, you just use flatten array or flatten array and pass it to our neural network, and the neural network will work the way we have seen it earlier. Back propagation, then parameter estimation will work similar way as the neural network only. So nothing is changed here in CNN. Correct. And what is use of ReLU layer? So basically it is with the filtered map after transformation from after doing transformation or convolution, so it convert into the non-linear. So basically whatever so it will work through, pass it through all pixels, and then it what it does, it's like 0 and max is 0. Now if it is pixel in negative, it transform it to 0, otherwise that number pixel will be the output. Correct?
Yes, sir.
Very good. So I think we have done with theory. So what we are going to do is today work with image classification. So let me share my screen. Can you see my desktop?
Yes, sir.
So again, we are going to have a classification where we have to classify either the image is cat image or dog image. Okay, so we have training set. So how you have to, when you are planning to run a image processing, you have to segregate, first of all, you have to segregate data. Okay, so all dog data is it in one folder. Just see this. So you can see there are different types of dog, and there are different types of cat data is there. So basically in training data set, you have cat data, you have dog data. You can see, okay, dog already you have seen. You see different cats. See, there are different types of cats are there. Some beautiful cat, some dangerous looking cat. And even pixel size are different. Image size are different, correct? Correct. So we have different cat and dog data. So what we have to do is we have to run a classification model, and whatever we have learned through the CNN theory, we'll implement it. So what you have to do is you have to open a notebook. Again, you just start a Cobol notebook, Colab notebook. Do you know how to do it?
Yes, sir.
Yeah. Yeah, do it. बाबू जा तो बाहर। So all of you have opened a notebook in Colab.
Yes, sir.
Okay, so this is going to be the big data set. So what you do is you do go and change the hardware. So just select TPU and then save it. Okay, I've already done, so I'm just cancel it out. All of you have changed it. Then what you have to do is you have to first import library. First of all, you have to import the TensorFlow as TF, and then you have to import this library called image data generator. Let me know once you are done with this and run this. If it is error, then there is typo. So image data generator is a module in Keras which is used for data augmentation. And what is data augmentation? So you have a, so basically in image processing you need lots of different images, and that sometimes it is very difficult to collect so much of images. So there is a technique called data augmentation. So what it does is it will, from a image, it will create multiple images, like some of the images increase the brightness. Sometimes they rotate images and different angles. So basically from a same image, they will create multiple images so that during training you will have enough data so that you will not overfit it. So that is image augmentation. So image data generator is nothing but a module in Keras which is used for image augmentation. Okay. So next is you have to upload your data. So what I want you people to do is you already kept your data in Google Drive. So you will upload it from the Google Drive. But to upload it from Google Drive, you have to mount it first. Okay, so how do you mount your Google Drive? So you have to from google.colab import drive and drive.mount G drive. So Google Drive will mount here. So basically you are accessing all your files present in Google Drive can through Colab. If you have any doubt, let me know. Any doubt? So have you got this or not?
Yes, sir. Okay.
Okay, so you just open this link. So it will ask you which one do you want to, which drive you want to mount. So let's say I have selected this because I kept it in this. I have multiple email ID. I just wherever I put data, I just put it here, and then ask to allow. Actually, it will give you a code. You have to copy this, and then where is it? You have to paste it there and then put enter. Okay. Then it will say that your Google Drive is now mounted. So mounted at / of GD drive, correct? Have all of you have got this?
Yes, sir.
Okay. So you can go on your left hand side. You will see there are different icons presented in left windows. So last one, files, you have to click, and then there is something up arrow is there. You have to click that. So you can find your G drive here. Hope so you will get it. So your G drive is here. Okay. And G drive, you have to locate where is your file. So in this, where is my file? CNN dataset is the file name. Okay. So once we get it, we have to give the location. Okay. But before that, so all of you are able to get this directory. So directory will come G drive. I have lots of file actually, but you have to locate where is your file. Okay. Are you able to get this G drive?
Yes, sir.
Okay. So are you able to locate your file?
Yes, sir.
Okay, very good. So first step is processing, data processing step. Okay. So there's something called train data gen. So basically we have to create first an object, and then we have to pass data on that object to process it. Correct? So first is what is it? So you have to call your data augmentation module, something called image data generator, and rescale is equal to 1.255. What is this 1.255? 1./255.
we are normalizing it by dividing it with
So we
255.
have a matrix this time. So basically what we are doing is we are normalizing every element so that all elements will be in between 0 to 251. Correct. So matrix division, this is the way to do matrix division. 1 dot of 255. Another is share range. So what is this share range? So basically we'll go and see what is share range actually. Actually, I just opened it. Yeah. So this is what share image is. So how many of you are using Stack Overflow? So basically when you use share image, so image will get distorted. So basically this is the way you see any image. So it will provide, so you change different angle to see different images. So it may be person who took these images are standing different places to take this image. Correct. So how this computer will recognize or identify same thing? So basically this is the something called CR images, where you have to give how much distortion image will get distorted. So you can see there is the original image after distortion. This look like this, same image look like this, same image look like this actually. So basically it provides some sorts of distortion in this. So basically from image randomly it will go pick some image and create distortion. What the sheer image is doing. And then zoom range. So again it will go find some images, create, it will go and zoom this image, zoom out, zoom in this images, and something called horizontal flip. So basically there are few image augmentation we are doing so that when we do training here, we should not overfit it. So that we are just creating different data set here. See, horizontal image is nothing but your image. Actually we are just creating a mirror image of the image. If you really want to see what are the different pre-processing tips, so what pre-processing steps, I just included few. You can go and explore more. So what you have to do, you go to Kira libraries and then go to data pre-processing. So image data pre-processing. So you can see for pre-processing actually there are three things. One is image data, another is time series data pre-processing, and then text data pre-processing. So since we are working with image now, we'll go and see it. So you can see there are different way of doing this actually. You can read this. Even there are different way to load that image also. So you can read this. Okay. So see this. There are multiple actually, and there are description available for whatever pre-processing steps are there or augmentation steps are there. Understood? Any doubt?
No, sir.
Okay. Next is we have to connect this with the data. Okay. So train data gen is the what object we have created or our choice of augmentation, and that's flow from directory. Okay. So I told now there are different method to upload the data also. There is one is flow from directory where you have to give the path name where and how to get the path of the data. How do you get? So you go to this training data set, copy path. Can you see this?
Yes, sir.
Yeah. You just copy this and paste it here. Done. And target size is equal to 64 cross 64. You can give it up to 256 cross 256, 256, but that will again create problem actually. During training, it will take lots of time. For time being, you just create 64 cross 64. You have seen that images are of different size. So we are asking them to create same size image of 64 cross 64. Okay. You have to give batch size. So again, we have seen it. There are multiple algorithms to run. One is gradient descent, stochastic gradient descent, batch gradient descent. So here we are going to use batch gradient descent. So you have to give batch size actually. So 32. There are you can try it out with different batch size also and see how this performance changes with the batch size. You can keep as a tuning parameter also. So batch size for time being, you just keep it 32. And class mode is equal to binary because we are going to solve a binary classification problem. Are you able to do this? Are you able to do it or not?
We're doing, sir.
Yeah, do it. So how many of you are doing it? Because so many people have requested data at the end of the before just class is starting. So how many of you are practicing it? How many of you are just sitting ideally?
Practicing, sir.
So at least 50% of you people are doing it, correct? So again, you start pre-processing the test set. You have the training set. Again, you have the test set. So do same thing with the test set also. So augmentation and all you have to only do with the training data set. You don't have to do with the test set, because during training only you have to create different sorts of images from the original image and then process it. Correct. For test data, you don't have to do all this. But you have to do scaling, because your test data, train data has scale, so test data will also be scaled. So have you done with pre-processing test data?
Yes, sir.
Okay. So so next what we have to do is we have to start building our convolution. So first of all, you have to create a instance of your model. So CNN equal to tf.kira.model. Again, we are going to have a sequential approach like earlier. So when you do it, you just run that piece of code also. So first step is convolution step, correct? So what you have to do is cnn.add tf.kira.layer convolution 2ds. Why we have 2ds here? So if you want to get the information about what this exactly methods are doing. So you can just hover over it. It will give you overview exactly what it is doing. So there are three types of convolution layer. One is 1D convolution layer. 2D is usually we do it in image classification, and there is something called 3D convolution layer. So 1D convolution layer, usually we deal with time series data. If we have a time series data, we'll do that. 2D when we have such type of problem, classification. And 3D convolution layer when you have 3D images like CT scan. So you go.
Sir, hello, sir. I'm facing
Yes.
some problem in training set. There is some error. Please
Okay, very good.
show
So we'll go to the
output.
training step and see exactly what error you have. So you know from where I got this, na?
Yes, sir.
Correct. So what you have to do is again you have to go here. You have to go to training set. Correct. And then copy path. You will get this one. Sorry, test, na? This is test one. Okay, you have problem with training. Correct. Here. You are here only. Just check.
Okay, sir. Done.
Very good. So test you have done with, training you have done, test also you have done. Correct?
Yes, sir. Done, sir.
Okay. So convolution operation. So first step is convolution step. So we are doing convolution using 2D convolution filter. So there are multiple convolution type 1D, 2D and 3D. We are using here 2Ds. So filter equal to 32 means we are using 32 different types of filters. Kernel size is nothing but your filter size. So we are using 3 means it is 3 cross 3. So filter size is 3 cross 3 and activation is our value and input step is 64 into 64 comma 3. So how this come? Because we asked them to create all images into 64 cross 64, correct? Here. And 3 is because this is a colored image. So 3 is the for this color. Understood? And then you have pooling step. So second step is after convolution, you have to do pooling step. So again, we are using max pool 2D only. Pool size equal to 2 and stride equal to 2. So stride, if you want to know what is this stride and what it is doing, I will send you link. So pooling step is complete.
Yes, sir.
So again, then again you just copy paste it. So that will be another layer of your CNN. Correct. So second time you don't have to give input shape actually. First time only you have to give input shape. So other things is going to be same. So you just add convolution layer. So that is easy actually. You have to just copy paste it. So adding layer in CNN or artificial intelligence or ANN actually, you just have to just copy paste. So after pulling, what you have to do is flatten all your data. That flatten means, so your filter map is in matrix, you just flatten it and make it as a vector. Once you flatten your data, other things is like earlier. Okay, you just add one hidden layer and one output layer. That's all you have to do. So up to flatten, you are done.
Yes, sir.
And then you have to just add a hidden layer. So again, you hidden layer have 128 neuron and activation is ReLU. Last layer will be output layer. Simple, that activation function only you have to change. That will be sigmoid. Once your architecture is ready, you just compile it. Again, we are going to use same thing. Optimizer is equal to ADAM, loss is equal to binary cross entropy, metric is equal to accuracy. Okay. Once it's done, you start the compiling CNN. Have you done with compiling? Done? Training CNN?
Yes, sir.
So have to compile, and then you have to just, once our architecture and compilation ready, you just use this fit method to just bring your training set and it will also do your validation actually and test, and epoch equal to 25 or 10 whatever 15, just keep 15 actually. Can you train and let me know what is the accuracy you are getting? So all of you report your accuracy in so all of you report accuracy in chat box. Just see, are you able to run this? Are you able to do this? Your net training has started or not? Are you people able to train your network?
Doing, sir.
Is it happening?
Yes, sir.
It will take some time. I think you are only doing, otherwise others are just enjoying it. How many of you are doing it? Really? How many of you are doing?
So doing it, but facing some problems.
So you have to ask me, na? Facing some problem, you are not asking. What problem you are facing?
The data was not uploaded on my drive. So I'm
The
uploading it
data
now.
still you have not uploaded, then what I can
It
do?
was downloaded in the local.
So how do you do then?
I was trying in Jupyter mode, but there's some error in it. It says no keras.layers has no attribute conf2d.
So I think you have done some mistake actually. So anyway, you people, whoever not able to download data, na, you just download data. Quickly we'll run it on Thursday or it may be on Monday. Okay. So training will take time. So what you people have to do it, you just message me how much accuracy you are getting. Okay.
Sir, 0.7939.
Yeah, very. So I think most of them have not downloaded data actually. So we'll run the same case study it on one more day, and also I will give you information about different architectures. Okay. So we'll stop here.
Okay, sir.
We'll stop here now, and then we'll meet on Monday. Okay.
Yes, sir.
Okay, sir.
Okay, sir. Thank
Okay.
you.
Good night.